All right, guys. This is day one on law of sines and cosines. The only reason it's day one is because this section also covers area of triangles and some weird area formulas that I don't know if you've seen before. So today we're just going to review law of sines and cosines. But I know for some of you, you never spent a lot of time learning about the fact that you remember that weird theorem in geometry that you could never use that spelled a bad word? When you were proving triangles congruent, there was SAS, SSS, and there was no ASS, right? Well, in law of sines, when you have that situation, there's a possibility that it won't make a triangle, that it will make one triangle, or that it could make two possible different triangles. And we need to figure that out today, okay? I don't know if you did it if you took trig, I think, talked about it. If you took only honors geometry and honors algebra 2, you maybe didn't do a lot of the ones where you had two possible triangles. So that's our goal today. All right. So the thing for law of sines and cosines is that it works when you have non-right triangles. It also works in right triangles, but it works in what's called oblique triangles. We no longer have to have a right angle to be able to solve the triangle. All right. They will use capital letters for the angles and lowercase letters across from those for the sides. Do you remember that notation? Okay. And your very favorite, when they say solve the triangle, it means you have to find all the missing pieces that they haven't already told you. Now, the homework has a few solve. I will tell you on the quiz, I generally only ask you to find one missing part. Okay, because otherwise, if you use the missing part wrong, it's kind of double jeopardy thing again, right? So I try not to do that on the quiz. All right, law of sines says the proportion will hold for the sine of an angle to the opposite side. You can use any two sets that are across from each other. And it works whenever you know two angles are what we're going to talk about first. So you could have two angles in a side, or a non-included side, or an included side. Why does it, if you know two angles, do you really know all three? Remember, because we add up to 180, right? So that's why it works. As long as you know two angles, you know all three, and then any one side, and you can do law of sines. We'll talk about the other situation in a second, but first, let's do one like that. What mode do we need to be in? Okay, they're giving us 30 degrees and 100 degrees, so we need to be in degree mode. This is a situation where we have this 30 degree is across from a side that's 15. I really wish they put labels on these. I don't know if it's 15 feet or what, but that's a length. So we want to find side B first, maybe. So we can say the sine of 30 is across from a side of 15. In the same way the sine of 100 is proportional to side B. It's really important that you remember to close your parentheses because the calculator brings up opening parentheses and you won't get the right answer if you do this all in one step anyway. So I usually, that's a B, sorry, it looks like a 6. I usually just type 15 times the sine of 100 divided by the sine of 30. Is that okay, or do you need me to write it out in steps for cross, multiply, and divide? We're good? Anybody getting an answer? I do everything to the nearest 10th at the end of the problem. Some of the directions say round angles to the nearest degree. I would prefer you just did the nearest 10th. I usually carry extra places until the end. But 15 sine of 100 divided by sine of 30, 29.5, anybody? Okay, and that's a, whoops, why did I write 4 then? That's a unit of length. So I'm going to write units, but it doesn't have a label. All right, we need to find C now. How are we going to find side C? Yeah, we're supposed to solve, so we probably should have started by finding the easiest piece of all, which was angle C, right? 180 minus 130 leaves 50 degrees at angle C. We found side B down here, so we have left to find side C. So we can set up the sine of 30 is across from 15. I'm going to use those because I know those are right. In the same way, the sine of 50 is across from C. We also rounded the B, and if we use the rounded value, sometimes it'll make C a little bit different. Please be typing these in so you know you're getting the right answers. So if you're not, we need to check whether you're in the right mode or you're not doing a parenthesis right. Or this actually rounds to 23, I think. Did you get 22.98? Everybody good? No. Okay. Tell me what. Oh, are you check you're in degree mode? You did that already? You are in degree or you weren't? Okay. Did it work? You should just hit enter again and it should recalculate it, but okay. Do you want to do one or two? We really don't need to do two examples of this, I don't think. Do number one? Okay. So if we want to solve for all the rest of the missing pieces, we're missing side C, side B, and angle B. It'd be pretty easy to find the angle, right? 180 minus 150 minus 20, 10 degrees at angle B. Who can tell me how to set up to find side B? Sarah? Good job. I got 69.5. Yeah, some of you probably found C first, that's all. Okay, 69.5 units. And then some of you found C already. And it's not drawn to scale. Do you notice that? It doesn't look, but a good check of whether it matches is the longest side is still across from the biggest angle, right? Do you remember that geometry property? The smallest angle has to be across from the smallest side. So to find C, oh my goodness, I don't know what I just wrote. Sine of 20 is across from C. Sine of 150 over 200. Is it 126, 136? I kind of remember something like that. All right, any questions? Everybody doing okay? All right, we'll skip to it's more of the same. Now, when you get to this bottom part of the front page there, it's trying to show you why we don't have this bad word theorem, okay? The donkey theorem doesn't exist, okay? We were using it or trying to use it in geometry to prove that triangles were congruent or not. Do you remember that? Okay. And the reason we didn't use it is because it doesn't determine one unique triangle. There's three different things that could happen. Given a 30 and a 2 and some third side here, a 30 and a 2 and some third side here for each one of these pictures, okay? That third side, if it was like a 0.3, it would just kind of dangle there and never touch, won't make a triangle at all. Okay. That's going to be kind of weird when we do the law of sines. It's going to show up in a weird way. You're going to find it's not possible. The other possibility is that it works fine. If it's 0.5, we'll say it would work fine and make a 90-degree angle. So it's one unique triangle. But the third possibility is that if that third side was 1 inch, so what I did is I put my circle tool here at B and I set the radius to 1 inch. Do you notice it intersects the line down here at 2 separate places? Okay, because it's possible that there's a bigger angle up here. Actually, what's going to happen is there's going to be an acute angle here or an obtuse angle down here when we set up the law of sines. Okay, it can be 2 different places. This is what I need you to look at so that maybe this makes a little bit of sense to you. Is everybody eyes up here? This is a sine graph in degrees. Does that make sense? 2 pi is 360. Halfway to there is 180, right? So when we set up a question like this, was it 30 degrees, guys? This side was 2, and we were trying to find, oh, we knew this side. We were trying to find this angle. So we would set up sine of x over 2 equals sine of 30. It wasn't 0.5 though, was it the last picture? 1? Thank you. When we set up this situation, we're doing inverse sine, right? So we do 2 times 30 divided by, or 2 times the sine of 30 divided by 1. Okay, that's a really bad example. Doesn't work. All right, I'm going to change their numbers. If we change this to 28 degrees, so do 2 times the sine of 28 divided by 1, 0.938. Okay, do you notice up here at 0.938, how many times are we going to hit the sine graph? 2 times. So if you do second sine of 0.938, okay, you get roughly 70 degrees. Is that what you're telling me? So at 70 degrees, it hits here. How are we going to find this other place where it hits? This distance is 70 degrees, yes? Do you see any symmetry going on here that we could look at? Yes, 180 minus 70 is 110. Okay, I want you to do this on your calculator for me. Type sine of 70, enter, sine of 110, enter. They're exactly the same. The issue is when your calculator does second sine, it always finds the one answer closest to the origin. So it found the 70. It didn't find the 110. Why do we care about this now and we don't care about it with cosine? If I drew a cosine graph real quick, this would be 360, yes, everybody with me? This would be 180. How many times do you hit before 180 with cosine? Only once. If you had something bigger than 90 in your triangle, it would have a negative cosine. See that? But we can have triangles with both 70 degree or 110, right? Not both at the same time, but one or the other. So we have to look at the possibility that there's 2 separate triangles. I don't know why they have such a bad example here, but anyway, you get the idea that there can be 2 examples. How did we find the second one? Whenever we do this, we find the value of an angle. Okay, we do second sine of some decimal, That gives us the first possible angle. Write this down under your little paper there so you remember. How do you find the second one? Yes, 180 minus that first possible angle will give us a second possible angle. A whole bunch of the time, you're going to get to throw that second angle out. For example, if I have a 60 degree, and when I did the law of sines, I got an 80 degree, what's the supplement to 80? 120. But if I had a 60, can I also have a 120 in the same triangle? No, it would add up to be 180 already with only two angles, okay? We'll do an example here in a second, but if this was 36, and when I did second sine over here, I got two possibilities over here. One was 72, we'll say. What the supplement would be 108. Are those both possible with a 36? Can you have a 36 and a 72 and something else? Yes. Can you have a 36 and a 108 and a something else? Yeah, there'd be 44 left over, 34 left over for that angle. Okay. But no, you can't have all three of them, but either one of these would work. Okay, but what if this was a 50 and I go over here and I do second sine and I get 83 or 9, I gotta make this bigger. Okay, it's gonna happen. Just give me a second. If this one turns out 80, this one started out 80, and this one turned out 70, okay? The other possibility would be 70 or 110. Can I have an 80 and a 70? Yes. Can I have an 80 and a 110 though? No. So I would throw that one away. Okay, just a quick example. We'll see some examples here in a minute. All right, there are rules for when there's one triangle, two triangles, or no triangle. These are the rules. If side A is less than side B and side A is less than side H, blah, blah, blah. I don't know these rules. I don't want to ever have to memorize these crazy rules. Just set up law of sines and it'll take care of itself, okay? I'll show you. Here's the, let's try this one first and then we'll go back to that one maybe. This says, it says in the book you should try to draw it to scale. I have a horrible time doing that. I'm just telling you right now. This says there's some side A that's 12. There's an angle B somewhere that's 61 degrees. And there's the opposite side over here. This side B is supposed to be 8 units long. All right, so what are we going to find first? The only thing we can set up, because these are across from each other, these are across from each other, so we can find the A. So we would set up sine of A is across from 12, in the same way sine of 61 is across from 8, and we type that in. We will get some kind of a number. Right. 12 times the sine of 61 divided by 8. Oh, I typed it wrong. Get 1.311. Your next step would be to do this, right? To find angle A. But can the sine be greater than 1? No, and when you do that, even if you didn't realize it, when you did that, it would give you an error, yes? What do you think that means about this picture? Yeah, what's really happening is this 8 is dangling around up here, isn't going to ever touch, okay? So this is not possible. Do you see that I didn't have to memorize any weird rule? It just turned out at the end with an error and I knew it was not possible, okay? Now, this one actually tells us it's going to be two triangles. But if it didn't, I'm hoping we would figure it out. I'm going to show you why. All right, it says side B is 10, side A is, angle A is 38, and across from here is an 8. I don't know if it's touching or not, but that's all I have. Okay, B, A, little a. Now what? What would I set up to find first? Angle B. Okay, make sure you're paying attention. If you have been doing something else, this would be the most important one we've done today because it's going to have 2 solutions, and I need you to understand this. All right, this up, and we get the sine of B is what decimal? 0.7696. Like some craziness like that. Just leave it in your calculator and do the sine of that crazy decimal, and you get what? Now, anytime you do second sine, you should examine the possibility of another one. And how do you find the other one? 180 minus 50.3 would be, yes. Okay. Now, the question is, can we eliminate either one of those? Could this be 50.3? Well, you'd have a big number across from a long side, a little number across from a littler side, and you'd still have room to make it add up to 180, right? Okay, so 50.3 is going to be one of our possibilities. The other possibility, could this be 129.7? If we did 180 minus 129.7 and minus 38, there's still left over 12.3 degrees. And we didn't finish this one. 180 minus 50.3 and 38. This one would have left us 91.7 for the other angle. Okay. This is the issue. Because angle C is different, we have to calculate side C differently as well. Right? They're 2 completely different triangles. People try to write down, oh, this is 50 or 129.7, and then they only give me one answer for side C. There's 2 different possibilities for side C. We're good? Oh, awesome. Awesome. All right, guys. We need to set up for C here, so we're going to have the sine of 91.7 is across from C, in the same way the sine of 38 is across from 8. Or the sine of 12.3 is across from C, in the same way the sine of 38 is across from 8. This one comes out like 12.99. Did someone get that? So we're going to round to 13. Yeah. Anybody not getting that? Anybody doing that calculation and not coming up with that? And then 8 times the sine of 12.3 divided by the sine of 38, 2.8. Now, do you remember the rule about the sides? The sum of any 2 sides of a triangle has to be greater than the third side? It does work over here. It's just going to be a really funky triangle, okay? It has one really tiny side and angle and one really big one, but it would work. All right. Let's talk about law of cosines. Ready to try this one? Do you need me to make up one more example where it only makes one triangle? No, we're okay? All right. Law of cosines is used when you know, generally we like it when it's used to find a third side. So if we have a triangle that has a 70-degree angle in here, and this is a 11 on this side and 13 on this side, we can find this side. Why can't I use law of sines in that situation? Nothing's across from each other, right? All right. So the rule is the side opposite the angle we know, okay? So the opposite side squared will be equal to the two adjacent sides. So adjacent side number 1 squared plus adjacent side number 2 squared minus 2 times one of the adjacent sides times the other adjacent side times the cosine of the included angle, the only angle we know. It's written in letters here, but if you have an application problem, you need to know the relationship of those because your triangle on an application problem isn't going to have labels A, B, and C, right? Does everybody understand what's going on here? Can we try an example? You've all seen this before, yes? So just to clarify on my little picture up here, this would be X, this would be 11, 13, 11, 13, and 70 degrees, okay? We're going to do it with this question. That sound all right? So we're going to say the only thing I can find is side B first. All right. So I should call it B, I guess. B squared equals 8 squared plus 10 squared minus 2 times 8 times 10 times the cosine of 100. Okay? Crazy mess. Can I type in just to here? No, because all this is together, right? So I either have to type in the whole thing or I have to type in little pieces with all of this being as one. The reason I ask that is because when we do it backwards, somehow students think they can undo it the other way. But for now, we're going to type 8 squared plus 10 squared minus 2 times 8 times 10 times the cosine of 100 all at once in the calculator. Now, is that side 191? Oh, I got a square root still, right? What do we get? 13 point? All right. We rounded that, and so now it's going to change. We're going to get different answers here and here depending on our rounding. I'm just saying. All right. How are we going to find angle A and angle C? Yeah, we're going to use law of sines. So the sine of A is across from 10. In the same way, the sine of B is across from, a sine of 100 is across from 13.8. Just kidding. See, if it had units on it, I'd be better. I know I would. All right. Riley, do you need help? Are you okay? Okay. 10 times the sine of 100 divided by 13.8. I get the sine of A is 0.714. If I do second sine of that, I get 45.5. I suppose I should look, because I did second sine, for the, okay, do I have to worry about the possibility of two different angles? Because I already know I have 100, right? So this one can't be more than 100. Now, the issue is, if you do law of sines a second time to find angle C, you get a slightly different answer than if you subtract from 180. I'll be okay with either one. If you actually do law of sines again, it actually adds up to like 180.3 or 180.2 or something because of rounding issues along the way. if you just do 180 minus 145.5, you get what, guys? 34.5. If you do law of sines again, you get 34.8. Yep. Yeah, but the fact that somebody's going to carry this all the way through the whole problem without rounding at some point probably isn't going to happen. Yes. Okay. That's why I'm saying I'll take either answer. All right. All right. We need to use law of cosines to find an angle. This is just a study hint here, guys. It says when you're trying to find an angle, always try to find the largest angle first. Okay? This will guarantee that you've taken care of any possibilities of two triangles. You won't have to worry about it anymore because law of cosines has one unique solution. So to set up to find an angle, we didn't talk about this yet. This is when you know all three sides. You're going to use the same thing we just did. Which angle do we want to find first because it's going to be the biggest? C, because it's across from the 28. So we're going to write C squared equals. Now, what are the two adjacent to angle C? Yep, we already know C. Let's start right in with that. We'd have 28 squared. Thank you. What are the two adjacent lengths? So we do 20 squared plus 12 squared, then what? Minus 2 times 20 times 12 times the cosine of C. Now, I really would like you to look up here for 1 second because somebody's going to do this question. I use the same numbers, kind of, okay? But what somebody's going to do is they're going to do 20 plus 12 minus 2. And that's going to be subtracted over here or something. Would you do that in Algebra 1? I hope you wouldn't have made that mistake in Algebra 1. We could subtract both the 20 and the 12 over here. Would that be okay? But what are we going to have to do with this mess back here? Divide it. So what I usually do on this kind of problem, you can show all the steps if you want, but I usually subtract the 20 squared and the 12 squared, and then I figure out what that mess is before I divide it. You could write 28 squared minus 20 squared minus 12 squared. You could also divide it right away by that mess. But if you do that, you need parentheses top and bottom. I'm just saying. I usually just hit enter before I divide. So what do you get for the top? 28 squared minus 20 squared minus 12 squared comes out to 40. Okay. And the bottom, or this part over here, is negative 480. And that's the cosine. It's actually one we should be able to find in our heads, but because it's negative 1/2, and we know where cosine of negative 1/2 exists on the unit circle, maybe. It's negative, which means it's going to be an obtuse angle, right? So, yes. All right. Now, once we know that one's 120, and we go to do law of sines to find B or A, are we going to need to worry about two possible solutions at angle A or angle B? No, because we already have the obtuse one, right? All right. So we know angle C is 120. What do you want to find next? Okay, angle B. We do sine of B is across from 12 in the same way the sine of 120. You could do law of cosines again, by the way, if you really like law of cosines. Most of us just don't really want to have to do all that backwards again. 21.8, anyone? And then if we have 180 minus 21.8 and also minus a 120, left over for angle A is 38.2. I don't know if you do law of sines again. If you get exactly 38.2, you might not. You probably should because it was exactly 120. We didn't round anywhere along the way. Except the 38.2. All right. One application and we're done for today. If they didn't give us a picture, this would be a miserable question because it has directions and I know how much you love bearing problems, okay? This says they started at A. They knew straight south of them was a cabin at C, 8 miles away, but they wanted to go on a hike. So it says, during an orienteering exercise, 2 hikers start at A and head 30 degrees west of south. This is straight south, and they went off 30 degrees towards west, okay? But honestly, the picture's all there, so you wouldn't probably have even read half the problem. I know you, okay? I wouldn't have either. It says, then they hiked 6 miles to point from A to B. Then they went and headed straight for the cabin, which they knew was 8 miles south of where they started. We need to figure out how long they hiked in here. So what are we going to use? Sines or cosines? Law of cosines. So we're going to set up x equals 6 squared plus 8 squared minus 2 times 6 times 8 times the cosine of 30. I got 16.86. What do we have to remember to do? 4.1 miles. Was it miles? Yes, yes. Okay. They finally give us the label and I can't remember what it is. All right. We will do some more practice because we just basically did one of each kind today. We'll do some more practice on Monday, but we're also going to learn all the area formulas on Monday. You can start working on this, page 298. Anything that says solve the triangle, you should be able to do now. And most of the applications. If it says find the area, just skip it until Monday, okay? Does that seem all right?